Good. Now with more with the topology. So this is the principal line of production. So you have design objects in your database, and they contain meshes and materials. So and you can refine them. And then you put them into your architectural models, and then make a rendering of it. So this is CAD. This is good with Blender. My hypothesis is, and I will show you how it works, is that the architectural model most appropriate is done with code, and it's not complicated. And then the rendering is with these render engines. And Blender provides 3, and there will be another one soon. So it's the very rough ones, Blender here, and then it's for game engines, very rough and complicated to use. You really have to engineer the light and everything. And you have this ray tracer, which is called cycles. And this is what I suggest to do. And this makes your life easy to get it photorealistic without hassle. So you can take any other renderer in other systems. All this is not of structural difference. So what we have done and what I want to discuss is these interfaces here, how to get from here to here. It's a simple import. And from here to here is a simple, we use Python script, but you don't have to look at it at all. So this is what you set up your, it's the most simple thing, just to give you the idea how it works. So you, this is your architectural model. You got an idea what you want to do. We say this is module A. And we have multiple instances of it. So we have multiple times the same. So that's the architectural model. So then we have design objects or object design. And this is with CAD. So there we have different levels of design. So we have the column and the ceiling, for example. Ceiling and column. And here is the mesh and the texture. Make this plan. And this is of level of detail 1. It's called module A. This is used in the architectural design. And this is for your library. And do the same on level of detail 2. Same name. But different meshes and different textures. So this is how you organize your stuff. And then of course you can have meshes in different textures and different meshes. So, or you can mix meshes, textures in meshes. So, and then you can have meshes and different architectural models, and you can mix it and so on. And therefore it's important that you put that apart, organize it orthogonally. Make a library for this, for that, and here for your architectural modeling. So this is very simple. This is how to create the things in Blender. So this is example. So then I show you the code. Let's have a look. So let's stop it here. I give you a closer look to that. This is example 47. And this is the, let's look, this is the Blender. So we have ceiling here and column. This is ceiling 01. Go here and show just the visible layers. So this is, I used the layers for level of detail. So this is level of detail 1. And this is our level of detail 2. So in level of detail 1, I have the ceiling. The ceiling has this mesh, and it has this material as sketched. And the same with the column. Here, this is a mesh, and this is a material. The mesh is column 01, and this is a material dark gray. So if you go to object mode, then you go to the level of detail 1. You have copies of that. You have new meshes. And you see these are the meshes. Level of detail 1, level of detail 2. This is how I organized my database. So and this thing simply needs to be saved in your in a folder, just here. That's enough. Just put it there, keep it there. And you can have different libraries, no problem. Now, there's a tutorial how to get, if you make an architectural model in Blender, how to refer to other libraries, to your libraries and different libraries and so on, copies or links to these libraries, and put your architectural model in Blender. So this is how to do it in Mathematica. So this is my code. You need the Mathematica to Blender, this interface, and it needs simply one evaluation. So simply evaluate that, and all of it. You don't have to touch it. So I can discuss it, but don't do it. So this is our layout here. How to use it for as described in this tutorial. So this is layout 47, and you get the source via YouTube, and then to GitHub there's all the source of these videos. So this is how to do. You say my layout. You say I make an instance of module A. It's called module 01. It should be on floor 01, and these are the coordinates where to put it, and it should be on layer A1. So then a second X, a position X2, X4, Y2, Y4, module A, then put it on the other layer, which means on the other floor. That's your architectural model in the most primitive way. You have to embed it into your infrastructure of your design. So the infrastructure says, I want to have, this is, I have to change this, because I have it here. So this is the directory, the directory name, copy, put it here. So my directory, working directory is this. Then I want to have a layer for the prototype. It should be on 1. Layer for the first floor. The first floor should be shown at layer 1 and layer 3. This layer A2 should be shown at layer 2 and layer 3. So this is for your categorical organization of your plants. So you have a building of 2 floors, and we simply say one layer is the first floor, second layer is the second floor, and the third layer is both floors. So this is given by that. So then you say, I want to work with library 01. This is what we just made. So and then we say the ceiling should be level of the ceiling LOD2, column should be LOD, column LOD2. These are the names of our libraries. So let's show, no, go back to Blender. This is our library here. These are these names. Simply copy them, paste them, and put them there. So I want to have this library, this ceiling, and the column, and work with it. So then I want to organize my outliner for the building in a certain way. So it's not only the layers, but I have an outliner. So which is this part here. That's the outliner of your, not of the library. This is the outliner of the library. You want to have an outliner of your project. And then you say, scene is always the top thing here. That's always scene. There's a top folder. That's like your disk on your computer. It's always scene. So and then I say, prototypes should be the child of scene. It should be at position 00, and it should be layer P, it's for prototypes. Then I want to have building A, subfolder of scene. No offset, no rotation, but on layer A1. Then I want to have floor 1 as a child of building A. No offset, layer A1. Then I want to have floor 2 as a child of building A, offset in Z direction, and layer O2, layer A2. Very clear setup. This is the infrastructure of your building. So then, this is for the outline. Then I import the materials. I say, import from Blender, from this library, I can have multiple libraries, from this library, import light gray and dark gray. So, and they have to be in library, so you have to check it. If you go then for this here, you have light gray and dark gray. So you want them. You can have other libraries, take other colors or other materials with textures and so on. No problem. So I just have these names. Then you import the meshes. And in this case, we import the ceiling and the column, which ceiling is currently ceiling LOD2. If you change that to LOD1, then it gets the rough level. If you go to LOD2, then you get the detailed level, because it's organized like that in the library. So we import these two things. So, and then we say we want to get these prototypes to your, we want to create the kind of production of it. So the prototypes. So, and we say create group. In Blender it's called, prototypes are called groups. We say module A should be of column, dark gray, of layer in layer prototypes. Oh, yeah. No offset, layer prototypes. So look at it up as a certain tutorial. So therefore, this creates an object and puts that to module A. This creates another object. It's a ceiling in light gray, prototypes, and so on. On layer P, puts that to module A as well. Therefore, module A consists of the column and the ceiling. And it's called module A. So you can combine a lot of different things, and you can combine more and more things without any change. So over detail, you can add Leisten, screws, whatever. So another small, all the small details, you just add it. And simply add it to the module. It's a kind of sub-drawing. And this is a prototype. This is what like you have in front of big buildings. You build, for example, a piece of facade in front of it so you can examine how it works. So this is a prototype. And put more and more things, and then you say, okay, now we put it to the whole building. And then this prototypical setup here is called module A. And this is what we discussed here. Module A at floor 1, and then you are there. That's it. If we export that, give that, go for, now we have layout 1, export that, we need an, this is our directory name, it's here, we call it simply layout Python, and, no, wrong, that's nonsense. I have a directory here as well, this is a variable from here. No problem, layout, then the code, and that's it. Now go back. Why? Okay, go for layer 3. At position 2. This is always bad. No. I don't know what it is. Shit. Okay. What is this doing here? It produces this Blender code, this Python code, which is of the same structure as we did it here. So this is Python. You can print it, create it directly, and this is hopefully layout Python here. No. I don't know. So go for Blender. So what you do is you go for the text editor with a fresh thing, because your code now is a kind of production for the building. So with the graphics, you're always fixed with the result. If you're with the code, you're telling how to do it. Therefore, you don't have to care about the rendering. So it's like a rendering. So it's just make another one. So with the code, you simply say make another one, another building, another version, in another setup, shop. So and it's here the same. So now I hopefully can do this tutorial. So this is the Python code, and you simply say run this script, and here you see the outliner. We have the scene, we have building A, we have the prototypes. Prototypes have the ceiling and the column, so they have these meshes and this material as specified, copied from the other library to your project. And the building has floor 1, floor 2, everything is there as we programmed, and it looks like this. If you go for now the 3D view, this is the prototypes. go here for the visible layers. These are the prototypes. There are the ceilings and the column. First layer is first floor. Second layer is the second floor. And the third layer is both combined. And they are properly organized here in our outliner, as set up in the code. So the idea is, if you want to keep track of these things with these tools, and the same, for example, now, this is an inherited object, so it's a group object. So you can find what it is here, and then you see these, they are relations. So in here you see it's the parent is floor 2, you have certain things here, group, no, they are relationals, or here it's duplications, you see it's a duplication from module R as group. So and this here, for example, is a group object. If you go here, this is a group object. We have the relations here, groups, and you see this is module A with the certain layers and so on. So then you organize it like this. So all this is possible in Blender to organize it, but it's simply not there. You can't see it. So you have to turn around the whole story, and depending on where you're looking, and it's super complicated to keep track of that. Especially if you work with different people and so on. To keep that consistent, how to model and do these kind of things. So it's a kind of holistic way how these interfaces work to that. This is because architectural model is about talking, and it's not about seeing. You can't make an interface for that. You can make an interface for the mesh, for a single object and so on, but not for the architectural model. And it's getting crazy. So and look at all these different things with the outliners, with the classification here, then with the grouping, the group objects, with the layers and so on, with the scenes, it's here as well. So all this is super complicated to keep track. And look how simple it is here. So you have the infrastructure, keep that, make it once. You simply say, it's a little, you have to get used to it, but it's there, it's one view. And this, for example, this is a code for that. This is your layout. So for this very simple object. Very clear. So it's on one page. Tuck, tuck, that's it. So therefore I think if you want to get an overview of an architectural model, and we will have more of that, now with grammars to get these kind of redundancies. So this is a little odd. Of course you don't want to have all these lists of 10,000 of objects. Yeah? This keeps compact, so you don't have to do a lot here. This is very compact, simple. In all offices they have that. They say how to use the layers, how to use which kind of names and so on, how to make all these things. They have instructions how to do that. That's the infrastructure. So, and this now is a very simple database, and it will have 100,000 of lines, but there's nothing else, it's just that. So, and here, for example, you see how to get a huge grid of these things. So this simply is a loop to make a grid of 4 or 5 by 5 of these columns on multiple floors. So by that you simply can add simply a 10, and then you have another axis. Put that and then go to Blender, and then you have the whole story again. So that's this interface. Now I want to show you how to get, and this is about topologies and grammars, how to make that super simple. that you can keep overview about on these things. So now let's go for, so it's not about the infrastructure, anymore, but it's about to getting these things structured. So now now it's getting a little tricky. Then I have to be fast, just get the idea. So what I'm doing is, look at this. It's very few code. It's just to play. The key problem is to get the conception of it. So this is grammars and shape grammars and so on. So the first step is we need, if it's about positioning objects in space and getting control about which object position at which place and which size and so on, rotation, size, location. Then you need points in space, the first thing. So you can draw it do it with Blender. For example, you can simply make a drawing here in Blender, import it. So it's just simply an export of an OBJ file of Blender, and then drag and drop it to Mathematica. And then you simply say, make this mesh. Now I have a two-dimensional mesh drawn in Blender. So this is from Blender, and this three-dimensional thing. If I don't want to look for coordinates and so on, then I have, this is my mesh, and these are the numbers of the vertices and the connections of the vertices. So this is a master geometry of your building. So all the edges in our building. You can design it with a CAD system. Or you can do it in 3D. It's the same thing, the same story. Take that, make this, whatever it is, and you get the mesh with numbers. So you can do, for example, this hanging model of Gaudi. Simply make a mesh by program, get a simple function, apply it to the points, and you get these points in space. Or go, for example, for a picture of a floor plan. Have a floor plan. You go in here, and here you have the coordinate tool. Then you get the coordinates. Get these points. Then you have coordinates. Get them. These are the points. Then these are the lines. Do it for the verticals as well, the lines. Then you have this kind of master geometry of a CAD drawing of a building. You have the numbers here. Then you can say these are the indexed points, they are not coordinates. So this you say on 2.3, there is a corner. That's a point of interest. On 2.4, there's a point of interest. Wherever it is, you don't care about coordinates. Never. Never do it. So then it's 3.4. 3.5. So make this list. And this is a tool how to get the points, and these are the points in space to work with. So in our case, there are a lot of different ways how to do that. Important is points and space connected. So this is the most simple example for that. Now, we have these points in space. Just to get the idea, a grid. So next is, I simply say, this is a function. I call it NO1. It takes 2 points, and you say there should be a line if the distance between point 1 and point 2, the Euclidean distance, is smaller than 1, or smaller or equal than 1. So apply this to these points, makes a grid. Because this machine here checks all pairs of points and says if it's smaller than 1, connect. So we can, for example, make another function, NOT2, and we say it should be smaller like 0.5, and this should be 1.4. So then we have 2, we put 2 in here. If we do that, we get the diagonals. Very good, so like this, no? Very simple. So you can have a lot of different kinds of functions for that. Important is that, for example, with OpenStreetMap, or whatever you can have all the points of this world. And you simply say, that's the beauty of these machines here. You simply say it should not be G1, it should be our globe or OpenStreetMap. And look, give me all points, pairs of points which are closer than 1. And you get it. So whatever you have, so which means whatever points you have, this is working. So it's again a library of rules, how to do things. Yeah? And you see these libraries are not complicated. So you simply say Euclidean distance, smaller than 1, put it here, keep track on your library object, and that's it. Always like this. So now, next thing, and now it's getting beautiful. You say there's a production rule, the prototype, O1. And we put it at the graph, and we say we want to have, this is G1A, we want to have 0.8, it's this guy here, at this point is point A, and we want to add a subgraph with maximum 2 neighbors of it, and you put it in a certain size. So, for example, so make that, and this is a rule. So this is a prototype. So we say this is a prototypical situation because we want somehow work on the edge. You get that. So for example, if you say it should be 1, then you get always 1 neighbor. If you say 2, you get 2. You can have 4 neighbors. So and again, it works on the whole world, huh? If you have the data. Just get edges. So this is a function, say, if I have this edge, so I want to name point 1, V1, vertex 1, 8, vertex 2, E is the transfer rule, the mapping, and then I want to do 2 things. I want to have, this is a graph, G is a graph, I want to connect V1 with V2, and I want to set V2 to color red, give them a value 1, which is color red in our setup. So I would say, for example, this is in this case, this is the position of a column. So if this is a corner, then the next point there should be the column, or whatever. So it's getting wrapped. So this is the rule for production. And now you apply this rule on this prototype to test it. Which means this is a prototype. We can skip the 2. And we apply this rule here. And say, let's do it. No, it's not working. Let's okay, now again. Good. That's the numbers here. This is our rule. Yeah, here, now we are. So here, now we introduced an edge and put that to red, which means now we qualified it to put a certain element in there, something from a library, just first element. Or we can take this, can for example say this is column LOD1. Put it there and make a connection, whatever. So the beauty now is that this is a production rule. You put it in the library and keep it there. So it's simply called PO1. Now you take any other graph, so for example GL1, put this rule and apply it. And it's working at all edges. So it knows that the graph is isomorphic at all the other things. So you had 4 positions, you have 4 edges. So of these things, there are 4 of these things here. So we have it here, we have it here, we have it here, and here. So if you have a whole city or a whole plan of a huge building in all details with hundreds and thousands of different edges and so on, you will find all the edges and make a one and the red thing. No marker on that. Or we'll collect them and so on. Just by saying, take this as an example, do that, make a prototypical production, and do it. Oops. And then you have it. And now it's clear, huh? So I import this here from so if you have this library, close it. So you prove that this is a kind of the principal setup. This is a prototypical thing, showcase. Now you go and have this library in your office. You have a mesh, put it on the table, run your rule, and you have it. Got the idea, yeah? And I don't need to change any code. Now it's here in 3D. It's exactly the same. So you create the things in 3D, find the edges. Oh, where is it? Here. 3D. Find the edges, then you get this mesh. Good. So it's just this code here. Get this. It's the same function as we had before. Works in 2D and 3D, no problem. Because we don't make a decision, you can have 4D, then you can have it in animations, no problem. So have that. Take a certain point. Now it's a 3-dimensional, therefore you need to be more specific, so we need distance of 3. have the same rule. Now name it a little different because now it's P301 here. Now I have to evaluate that. Now we have, it's red. So that's here. That's here. Okay. Now this is the rule. This is the same structure, but I need different numbers because they have my prototype here has different numberings. Therefore I have to change just these numbers here, then give it another name and apply it to itself, and I get, this is always, I have to improve that. And you get the same story. And you run the production on our showcase. Good. Now, have a more complex and then we are there. Okay, now we are with our showcase. It's a two-dimensional setup. I was not, I will have an export to Blender with very detailed things to make real buildings with that. So to complete it, I was not able to finish that. So, but I think you got the idea with the prior exercises with the interface of Mathematica to Blender. Now here, this is the grid for the showcase. Now we have a set of rules. We say this is a rule who is able to detect the edges. So it simply takes here, for example, element number 8 with the depth of 1. It's here. So, and this is our prototype or the key for the detect edges. This is a production rule in short form. So we say 8 should be color 2. And here we apply it to our grid, which means you get all the edges, whatever it is. Now, this is the rule for detect the corners. So we take the thing, depth of at point number 1 with depth of 2. We get it with the color green. That's the corner detection. This is the corner production. Put it to number 1, which is red. That's the rule. This finds 4 instances of this rule. So if you have an established link to Blender, instead of rendering it 2D in the schematic way, you just can have a Blender render. So it's just the object there and putting it there. So just you simply organize your stuff in these production rules. So now we want to go for columns. If we have an edge here, then we want to do these things and replace the edge with columns. There should be columns at the edge and 2 different, with 1 in between, there should be a column as well. So there's a second rule for columns. If I have this situation, for example here, then put this here, 929, to column, to yellow. So this is the rule. This is a key, this is a rule. Do that and you get this pattern. Next, if you have this kind of position here, which is, for example, here, and these are jokers, whatever they are. So, for example, if you put it here, if it's here, yeah, around here, then you have it here. And then you say, I don't care whether they are already columns or not. So, they can be yellow, green, or whatever. I want to have a column here. So, this is our production. Put 19 to yellow. And this is how it works. And here we have a grid of columns. So now, this is an alternative, we don't need that. So, and this is a production line. That's our prototype and our showcase. We checked all the combination of the rules. 2D, 3D, with facade elements, with doors and so on, whatever. And then we have a set of rules in a certain sequence. And this is production line. First the edges, then the corners, then column 1, 2, 3. And this is how the production line works on GO2, which is a blank array of the grid. So, and then we want to have the third and the sixth element of that. And then you see it's doing the production. So now you get the positions of facade, edges. This is a different element than here in facade. It's always with the edge different. And this is the construction. So you have your position of the columns and the beams in between the columns. So this is the yellow stuff. And this is the facade. You need facade elements between the greens. And you need a special element at the reds, around the corner and the edge. So this is what you, if you don't want to work on the programming of that in the showcase, if you don't work on the production line of doing that, then this is what you need to do it with a different project. So if we say, for example, it's a square here, you say it should be like this, and you simply apply this thing to this, and you have it. So you have all the informations to get the interface for Blender. You know which element positioned where, in which dimension, and so on. And imagine the points are in grid, just to make a simple example. So we can have this hanging chain of Gaudi, we can whatever we like. Doesn't affect that. This is a question of the design object which reacts on certain parameters and so on. So it's just this kind of topology. So you can get around corners, having beautiful curved ceilings like in our lab and so on. It's just these things. And this is called grammar. And this is the architectural model on topologies. Which is the design part of the architectural model. And next week, or next time, so it's in 2 weeks, there's the last lecture, I will show you how this works with parameters. This is the other way how to make models. And these both in combination cover the whole story. So this is what I wanted to show. Hope you got the idea. If you have questions.
So it doesn't matter which form it is.
Yeah, it's no form, it's topology. Therefore, it's so important that you understand. Therefore, it's an architectural model, and you can't see it. Architectural models never can be seen. So they are rendered, and that's rhetoric. So it's an abstract thing. So this idea that in Blender you can see the thing, and this idea of virtual reality and so on, walking through and so on, it's the most stupid thing. So because you can't understand what computing is about. Computing is about like Rubik's Cube. It's just talk. So if you get these principles, you get super powerful. The more data you have, the bigger your libraries are, the more power you have. And it's amazing how fast you get and how controlled these things are. You can make skyscrapers like this. And everybody's happy. If you're able to establish that, it's and if you look at offices, they're all working like that, but they're mimicking it somehow. So they're struggling with all these problems, not having precise thinking about how it is. And the architectural model is not about visualization. It's not a sensible thing, it's articulation. And if you keep that apart, you're winning. You don't hustle around. So to get it into, but you see, for example, we started here with this Blender input here, with this 3D cube and so on. You can have an amorphous model, for example. If you start like this with these rules, you start with the master geometry in 3D of this rule, and then you subdivide it, and then you put the elements. That's it, and you're there. You don't have to draw anything but the coordinates. And then you can change the coordinates and the system still works. You don't have to redraw anything. There's no problem at all. The system might not work, so you have to add or change some rules, or the sequence of rules and so on, that you make to fill this corner and make an exception for that and so on. Exceptions always means another rule. And then you adjust the shape of it and do the production and look at it in very detail. That's the story, how it works. Another question? Okay, thank you. Have a good time.